Hey everyone! In this video, we're going to be taking a look at dilations that have a negative scale factor. So remember, the scale factor tells us how much bigger or how much smaller our shape is going to get when we do our dilation. But now a negative scale factor, it actually does something extra. So I want to take a look at an example and we'll talk through what this does. So the first thing, just remember the coordinate rule for when we're doing a dilation. If we have a point xy, the coordinate rule, we just take the x value and the y value and we multiply it by whatever our scale factor is. But now in this case, we have a negative scale factor. So k is going to be negative. But remember, when we're talking about rotations, the shortcut, the coordinate rule for a rotation of 180 degrees, we just take our x and our y coordinates and we make them opposite. So we put negative signs. So in other words, when I do a dilation with a negative scale factor, I'm basically combining these two things together. So I'm doing a dilation and I'm also doing a rotation of 180 degrees. So let's graph this triangle and do this example and we'll see if that fits. So F is 1, 3. G is the point 5, 2, 1, 2, 3, 4, 5, and up 2. And H is 4, 4, 1, 2, 3, 4, and up 4. So we have the point F, G, and H. And then let me connect these together to form our triangle. All right, so using our coordinate rule, we can follow along to see what happens to our points. So F is the point 1, 3. And now just taking the x and the y values here, we can multiply it by our scale factor of negative 2. So 1 and 3, both of those multiplied by negative 2, we get negative 2 and negative 6. And that will be for f prime. Let's do the same thing for g and h. So g is the point 5, 2. Multiplying both of those by negative 2, we get negative 10 and negative 4. And for h, this is the point 4, 4. Multiplying both of those by negative 2, for h prime, we get negative 8 and negative 8. So let me graph those, and then we can compare to what we started with. So negative 2, 1, 2, 3, 4, 5, and 6. So here's f prime. G is negative 10 and negative 4. 1, 2, 3, 4. That's g prime. And for h, we're at negative 8, which is over here, and h prime. So let me connect these together. So here's our image, f prime, g prime, h prime. And as we can see, it does fit what we talked about. So not only did the shape get bigger, so we dilated it with a scale factor of 2. It's twice as far away from our center of dilation, which was the origin. The segments that make up the triangle are twice as long. But also, because the scale factor was negative 2, we also have a 180 degree rotation. So our center of dilation also is the center of that rotation. So we rotated counterclockwise 180 degrees and the shape got a little bit bigger. So a dilation with a negative scale factor, again, it's a combination of a dilation and a 180 degree rotation.